All right, we're about to start a video for section 2.2, but I had a good question in class from section 2.1, so I'm sticking this on to the beginning of that video. How do you interpret negative of a negative of a negative, etc.? So if I have minus of -7, is that what you're talking about?
Yeah.
Yeah. Let's do this on a number line first, because again, I'm a big fan of the visual. My inner number, what's my innermost number? -7, right? This is that right there. This is just the minus sign means negative. So I'm starting here at -7. Then I have this, of the three minuses, this is the middle one. What does that do to the -7? It makes it positive. So this is telling me to take the opposite. So I'm going to come over here, and now I'm going to be at +7. That's my middle negative. But then I have another minus sign on the outside. And what's that going to do? It's going to bring it back to -7 again, the leftmost. It just bounces it back and forth. Yep. Negatives change the sign from one side of the zero to the other. So that first -7, when I make it the opposite, it becomes a +7. So the middle and the rightmost minuses cancel out and gives me a +7. But I still have this one that was the leftmost. And that gets me back to -7. A negative of a negative is a positive. So a negative of a negative of a negative is a negative, goes back to negative, and it just bounces it from side to side. Now, it's good to practice this because it shows up sometimes when you do math. But if anyone sat down and just said, hey, here's a number I want you to think about, you'd say, why? Why couldn't you just write that number? Okay, that's a great question. Now we're going to start section 2.2. We're going to use these integers with addition and subtraction. So here's our Math 60 video lecture for section 2.2. Addition and subtraction with integers. Quick review from chapter 1. Whenever we're working with all positives and we have a plus sign, right, that's our basic addition. I could see it on a number line. 3 + 5 = 8. I could see it on a number line as I start here at 3 and I take 5 more steps. 3 + 5, and I end up here at 8. So addition of positive numbers steps to the right. And if I have something like 9 - 7, again on my number lines. 1, 2, 3. I start at 9. and I'm taking away 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Then I end up at 2. Subtraction of positive numbers steps to the left. This works great when we're all dealing with positive numbers. But as soon as we allow ourselves to add and subtract negative numbers, we have to add a level of complexity. So I want to explain this in a completely different way. Well, no, it's almost the exact same. Positive numbers face right. Addition steps forward, i.e., the way you are facing. Subtraction steps backward, i.e., away from the direction you are facing. On the number line, positive numbers always face to the right. And then the operation, the addition or the subtraction, tells you whether you step in the direction that you're facing or you step away from the direction you are facing. This is going to help a lot when we start doing these same operations with negative numbers. So let's take our 3 plus 5 example again. So here's my 0, 1, 2, 3. I'm on 3. And the plus 5 or the 5 means face right. So I'm looking to the right. And the plus means step toward my direction. So I step in that direction, 1, 2, 3, 4, 5, and I end up at 8. Compare that to the 9 minus 7 equals 2. Here's the 9. The 7 means face right, still. That's supposed to be an eyeball. That's the way I'm looking. I didn't want to draw a whole face. But the minus means step away from my direction. So even though I'm facing to the right, I'm going to step 7 steps away from my direction, and I end up at 2. This is the very visual way to do it. And when we get to addition and subtraction with negative numbers, if this visual way isn't quite making sense, that's all right. We also have the symbolic way, which I'll go through. So if your operation involves positive numbers, you're always going to be facing to the right. If it involves addition, you're going to be stepping the way you're going. If it involves subtraction, you're going to be stepping the opposite, away from the direction you're facing. So let's apply that. Negative numbers face left. but still plus means step the direction you are facing. Minus means step away from the direction you are facing. Let's do 7 plus -2. All right, so it's a 7 plus, but the thing I'm adding is a negative number. So I start at 7. I'm going to be working with a negative. So which way am I facing? Left. Backwards, left. I'm facing this way. -2 means face left. It's cool if backwards works for you. I want to make sure that for others, okay. But I'm adding. I'm facing left, but since I add means I step the direction I'm facing. I step in that direction. So I'm going to step 1, 2 steps in the direction I'm facing, and I end up at 5. 7 plus -2 is 5. Symbolically, what this means is when you add a negative number, it's just like subtracting the positive number. 7 plus -2 is the same as 7 minus 2. Adding a negative is like subtracting a positive. Let's look at 5 minus -6. And we'll do it with the number line. Here I am at 5. I'm going to be working with what number? -6. So which direction am I facing? Left. So I'm going to face this way. -6 means face left. But I'm doing subtraction. So I'm going to step the way I'm facing, or I'm going to step away from that direction. I'm going to step away. The minus means step the opposite step away from my direction. So I go 1, 2, 3, 4, 5, 6, stepping away from my direction, and I end up at 11. 5 minus -6 is 11. And if we wrote it symbolically, 5 minus -6 is the same as 5 plus +6. Subtracting a negative is the same as adding. Now, the folks on the video can't see this, but I'm going to demonstrate physically. Let's see. So here's 0. Let's do 7 plus -2. So I'm out here at 7. It's -2, so I'm going to be facing your left. And it's addition, so I'm going to walk in the direction that I'm facing 2 steps, and I end up at 5. The reason I give you, I'm talking through this, which I understand is a little bit more complicated, is as soon as we introduce negative numbers, we can do a lot of different sorts of addition and subtraction that look confusing. So here are all the possible combinations using A and B as generic numbers. All right, so I'm not going to use 5 and 6 or 7 and 2. I'm going to use A and B. We've got A plus B. That's one combination. We've got A minus B. That's another combination. Those are the straightforward ones. But we also have A plus negative B and A minus negative B. And we also have, let's see, negative A plus negative B and negative A minus negative B. And technically, we also have negative A just plus B and negative A minus B. And that's not even switching which letter comes first. Right, so there's a lot of different combinations of arithmetic symbols we can put together just using plus and minus. And if and when you get stuck thinking about on the number line, I start at A, B is going to be a positive number, so I'm going to face right and step in that direction. I start at A, if B is a positive number, I'm going to face right, but I'm going to step away from that direction. Here's minus A plus minus B. So I start to the left side of 0. Minus B is going to be a negative, so I'm also going to be looking left, and I'm going to step in that direction. The book does it slightly different. The book talks about stacking arrows. But the problem with stacking arrows is it only works with the addition ones. It doesn't really work with the subtractions of negatives. That's confusing. So I like the sign of the number tells you which way to face. The symbol tells you if you walk in that direction or walk in the opposite direction. Practice will help. All the possible combinations simplified. So I'm going to write the same 8 combinations, and the ones that I can simplify, I'm going to simplify. A plus B, that's as simple as possible. A minus B, also as simple as possible. A plus negative B, I can rewrite as A minus B. Plus a negative is like subtracting the number. And actually, I am going to use some actual numbers here. So let's use 5 and 2. 5 plus 2 equals, it doesn't equal 3. 5 plus 2 equals 7. 5 minus 2 equals 3. 5 plus negative 2 equals 5 minus 2 equals 3. Then we had A minus negative B. So A minus negative B, that simplifies to A plus B, because subtracting a negative is like adding the positive. Five minus negative 2 is like 5 plus 2, which is 3. Then we have minus A minus B. Can't really do anything to make that simpler. We're just done. That's like -5 minus 2, which is -7. Minus a plus b. I could write that a little different. If I wanted to, I could write that as b minus a, right? Minus a plus the b, I could bring the b in front, and that would be like b minus a. That's like -5 plus 2, which is like 2 minus 5. What is 2 minus 5? It's -3, because if you start on 2 and you take 5 steps to the left, you're going to end up at the -3. Yeah. 1, 2, 3, 4, 5, 6. I have 2 more. What else do I have? Do I have 2 more? Yeah, I have minus a plus -b. That one is minus a minus b. So -5 plus -2 is like -5 minus 2, which is -7. And the last one is minus a minus -b, which is like minus a plus b, which I could simplify even one more time to b minus a. -5 minus -2 is -5 plus 2, which is 2 minus 5, which is -3. So you see there's a lot of possible combinations. And depending on how familiar you are with these, you can just kind of process through it numerically or symbolically, or you can use the number line as well. All right, one short little topic to finish this section. The book has a whole conversation about absolute values and things like that, and I find it to be really confusing. So it's like supposed to be a set of rules that you can use to remember what side you're going to end up on, etc. But instead, I'd rather write down the possibilities and have those as a reference. So the identity revisited. We said a plus 0 equals a for any number a. So 0 is the identity. You take any number and you add 0 to it and it doesn't change. 7 plus 0 is still 0. -8 plus 0 is still 0. Sorry, 7 plus 0 is still 7. -8 plus 0 is still -8. One consequence of that is a minus a will always be 0. Any number subtracted from itself is 0. And I can rearrange that and say the opposite of any number added it to itself is 0. The opposite of any number added to itself is 0. And we've used these when solving equations. Examples: 3 minus 3 is 0. -7 plus 7 is 0. All right, any number subtracted from itself is 0. And the opposite of any number added to itself is 0. And we use those to solve things like x minus 7 equals 5. Because we wanted to isolate the x, and so we added the 7 to both sides because -7 plus 7 is 0. And those cancel out, And we're left with x equals 12. Okay. I'm going to stop this video because we have finished this part of the video lecture, and we'll switch over to worksheets.